Hi guys, this lesson is for IGCSE, GCSE, year 9 or 10 about numbers. So in number system, we have different things in the curriculum. Okay. For example, the first thing what we should know is prime numbers and factors. So prime numbers, you have different numbers. For example, 1, 2, 3, 4, 5 and so on, but out of these there are some which are prime. So how to define prime numbers? The prime numbers are those which has exactly two factors. Okay, for example, we have number 2. It has only two factors. What is that? 1 and 2. We have number 3, 1 and 3. Okay, we have number 5, 1 and 5. We have number 7, 1 and 7. We have number 9, which has 1, 3 and 9. Therefore it is not a prime number. So we will not consider 9 as a prime number because 9 has three factors, 1, 3 and 9. But all these numbers, 2 has two factors, 3 has 1 and 3, 5 has 1. So all have two factors. One more thing, 1 is not a prime number. The very interesting fact that 1 is not prime is 1 has only one factor. So 1 has only one factor, therefore it is not prime. Okay, so 2, 3, 5, 7, 11, 13, 19. So list down some prime numbers from 0 to 50. So we can list down those numbers. If you understand first, then you can easily write down. So we can start with 2. We'll start with 3, 5, 7 and not 9. Okay, 11, 13, 15 and no, because it is odd but it's not prime. 17, 19, then not 21, 23 of course, 26 no, 27 no, 29 of course. So I hope you can complete this table for 0 to 50. Now let's talk about what is prime factorization, the second problem. Guys, you need to know what is factorization. Here I have shown you one example, and similar kind of questions you will see in your exams. So for example, 60 is already factorized as 2 squared times 3 times 5. So these are all prime numbers, 2, 3 and 5. So make sure you start dividing any number by prime. Start with 2 if it is even, start with 3, 5 and so on if the number is not even. Okay, that you can try with any other number. For example, if I start with 120, so I can start with 2 and now I can divide 120 by 60 times 2. If you carry on, 2 times 30 and then 2 times 15 and then 3 times 5. Now what you need to do, you need to circle all those numbers which are prime. 2 is prime, 2 is prime, 2 is prime, 3 is prime, 5 is prime. If all the numbers are prime, you just stop there and then convert 120 as 2 times 2 times 2 because it is appearing 3 times. 1, 2, 3 times 3 times 5. And then in power notation, you represent 2 power 1, 1 and 1. So makes 3 power 1 times 5 power 1. Okay, I hope this will help you to know how to factorize all these numbers. If you want to try for 325, so you should start with 5, I should say, because the last digit is 5, so it is divisible by 5, so you can start with 5. Okay, so 5 into 6, 30, and then 5. So 65, then again 5 by 13. Okay, and 13 is on the list of my prime numbers, so I can stop here to put them in circles. So 5 is prime, 5 is prime again, and 13 is prime. Okay, so you can represent 5 square times 13. So this is the exact notation you need to give your answer. Okay, let's go on second example. Yeah, here you need to fill these blanks. For example, it's a similar kind of tree diagram where you need to start with 210, then you need to fill here, but remember they already given you some numbers 5 and 3, so make sure you write a number which is a factor of 5 here. Okay, and then 3 here. So for 210, if I take different examples, for example 210, of course we can divide by 3. So 3 into 7, 3 into 7, so 70, and then carry on to 35, then 5 and 7, like this. Now once you got all the factors and all these are prime numbers, so 3 is prime, 2 is prime, 5 is prime, 7 is prime. So I can see 5 and 3 here, so you can just pair up them. So maybe 3 can be paired up with, of course, 7, no problem. So you can write here 7. I'll change the color. So 7 here. Okay, and so 3 times 7 is 21, and here 5 and 2, so it's 10. So this is the best way to deal with these questions. Okay, so make sure once you have all factors of one number, then you should fill these things. Now guys, based on factors, we have these terms HCF and LCM. Okay, some of you may call GCD or some other terms, so make sure you understand that. For HCF, I mean to say highest common factor, highest common factor, and here LCM means my lowest common multiple. So I will write here multiple because it's different than factors. Okay, so if I take one example, then I think it would be easy for you to understand what's the difference in HCF and LCM. Okay, for example, we have two numbers, one is 25 and second is 40. Okay, so if I talk about highest common factor, it means you need to factorize them. Okay, and of course you may follow any technique, but I would prefer prime factorization. So 25 as 5 into 5, and how about 40? Of course I can start with 5 times 8, and then 8 can be taken as 2 into 4, and further 2 into 2. Okay, so you can circle these 2, 2, 2 and 5. Here 5 and 5 all are prime numbers. Now when you see about highest common factor, okay, what you need to do, you need to cross all common numbers which are prime. So 5 is prime, 5 is prime, and it's common in both. So I'll write 5 here times. Is there any other number 5 another time? No, there is no. All are 2 2's. So it's not making any sense to write another number. So highest common factor of 25 and 40 is only 5. But when you talk about lowest common multiple, which is LCM, okay, so in that case what you need to do, there is a trick. If you want to follow that would be really grateful for you, and that will really help you for quick calculations. For example, you have two numbers A and B, and you have their highest common factor and their LCM. Okay, so there is a condition between a relationship between them. So the relationship is A cross B, means multiply, and the product of HCF times LCM, so they are same. So for example, I want to figure out LCM. I'll try A cross B divided by their highest common factor. For me, that's the easiest way to figure out LCM of any any pair of two numbers. So for example, here I would like to try. So LCM would be 25 times 40 over 5, because 5 is my highest common factor, which is 5. So I'll divide by 5. So you can divide either 25 or 40 as you wish. So if I cancel 5 and this 5 with this, so I have 5 times 40 as 200. Okay, so 200 my LCM. The other way is like you write all multiples of 25. Okay, so for 25 you can start with 25, 50, 75 and so on, and then you start with 40. Okay, 40, 80, 160, 120, all. So you will see 200 will be the first number which will be common in both. So that's why you can say 200 is the LCM. We'll see some examples more. Here there's also this way of representing HCF and LCMs. You can see find HCF and LCM of 24 and 36. So the way they followed, factorize 24 like a prime factorization, and 36 for highest common factor. As I just discussed with you, you just need to do the common numbers. For example, 2 and 2 is common. Yes, we can write 2. Another 2. Yes, another 2. Okay, third 2. There is 2 here, but there is no 2 here. So we'll go on cross 3 and 3. Yes. So the product of these common factors, which are common, highest common. Okay, so 2 times 2 times 3 is 12 is the highest common factor. So you can use a Venn diagram to represent this. So for example, the first circle is representing for 24. The second one is representing 36. So the first circle, the common area, you may write all these factors here. 2 times 2 times 3. So all are here. And now the remaining factors, the remaining was 2. So I'll write 2 here, and here 3. So you write here. Now in LCM, if you multiply all, you'll get your lowest common multiple. And we can verify with the previous technique what we used. So LCM as A cross B over highest common factor. So 24 times 36 over 2 times 2 times 3, maybe 12, just write 12. Okay, so 36 over 12, it's 3. Okay, so 24 times 3 is 72. So that's what you get. So you have different techniques to use these. Now you have different examples, 60 and that, 70 and 54. Please try, get back to me in comments what you don't understand. Thank you.